All right, so let's dive into commands. And we're going to start with the TeleopSwerve command. And in general, we strive not to extend the command class unless we feel like we really need to. So in 3061 lib, the command class has been extended 3 times, once for TeleopSwerve, once for ArcadeDrive, which we use with the XRP, and once for drive to pose. Otherwise, we try to use the various command factory methods and decorator methods to build up the commands as needed for more sophisticated operations. But we felt like these three warranted their own subclass of command. So we'll jump in here and look at the drivetrain, or look at TeleopSwerve first. What this class is designed to do, this is the default command that runs on the Swerve drivetrain. And it takes the inputs from the joysticks, the controllers, and has the robot drive appropriately. This command, however, also supports the drive facing angle feature, meaning as you drive around the field, ignore the, don't you look at the rotation joystick at all. Instead, use a different supplier to know at what angle you want the robot's rotation to be. That can be very useful, for example, when tracking something like a target. For example, in 2024, you might want to drive around the field when you have a note, and make sure that you're always aimed at the speaker. So some interesting aspects of this class. So to support that, we have 2 different constructors. The one that we normally use here takes a double supplier for the rotation. Everything gets initialized. The other one here takes a supplier of a rotation 2D. So that's going to come from some other code elsewhere that, for example, based on the pose, would calculate that angle. And therefore, we would set drive facing angle to true, whereas up here we set it to false. Inside the execute method, which will be executed at least once, and then every loop thereafter until the command is finished or is interrupted. You can see here where we get the X and Y values as we go. You'll notice that we call this modify access method, and it passes in the power as well. This allows the driver to do some tuning here. So we use a tunable, which we can change without recompiling and redeploying the code if tuning mode is true. So the driver can see to what power they want to raise their joystick inputs. Our most recent driver found that squaring it worked best for him. And then this modify axis one handles some of the interesting coordinate system differences between driving on a field and the joysticks themselves. So this method here applies a deadband. So deadbands are very important. There's some more sophisticated approaches out there. We find that works just fine. And then here we raise it to the power, and we use the copy sign method, so we don't use the sign as we square, for example, the joystick value. So that's what's going on there. So we get our X and Y percentages based on the maximum velocity of the robot, which again comes from the robot config object. We then turn it into a velocity. If we're not drive facing angle, we do the same thing for the rotation. We log everything, so we know what our intended X, Y, and rotational velocities are. And then we invoke the appropriate method on the drivetrain. So either the drive method if we're not doing drive facing angle, or drive facing angle if we are. And that's about it. This command doesn't have an isFinish method because it will never be done. It will be interrupted at times, and it will end for that and then start again later, but it will never end on its own. The ArcadeDrive method is very similar, but very straightforward for the XRP. We're simply getting the X and Y, the X value and the rotation value here for the turning. We're not doing deadband stuff. We're not doing raise to power stuff or anything complicated like that. Maybe we'll add that in the future. We'll see. how the XRPs drive. Um, so those are the two basically drivetrain related subclasses of command that we use in 3061 lib.